another class to work on for their lesson. So we're looking at, in our textbook, lesson number 11, and its name is More Solutions to Linear Equations. So just like we did the other day, I'm going to actually go out to the front just because I like to sort of chat with you guys, and I like to be at the board. So one thing I want to talk about before we get into today's lesson. So in that lesson video that you guys had to finish watching on the lesson video that you had to finish watching on Friday for our lesson, I'm a little bit bummed because at the end of that video, I sort of put like this phrase that I wanted you to email me with just to make sure that you watched the video, and only 5 out of 19 of you guys sent me that email letting me know what that phrase was. So I was a little bit bummed just because I took the time to create that video for you guys so that you didn't have to go through and just sort of go through it on your own. So it just makes me a little bit bummed that people didn't watch it all the way to the end. So in these videos from now on, there's going to be 2 things I want you to know. So sporadically throughout the video, it's not going to only be at the end. It could be in the middle of the video. There's going to be a secret catchphrase that you're going to have to email me every day to let me know that you watched the video. The people that sent me the email from this weekend are going to get a quiz grade in as 100. The people that didn't, I'm going to put it in as exempt, so it's not going to go against you grade-wise, but it will benefit those people that actually did watch it all the way through and took the time to send me that email. So if you didn't do it, that's like not the worst thing in the world, but I'm just know that I'm a little bit bummed because I took the time to create that video for you guys, to go through all the answers, and I would just love for people to actually watch it so that they can understand the topics that we were talking about. Does that make sense, you guys? So also in that, so the videos for today that I attached are actually attached as Edpuzzle videos so that now I can actually see how much of it you watched and who watched it. So if you look on slide number 7 in the slideshow, now it has 2 separate links. So the cohort 1 link is going to take you to, and it's going to log you in. It's going to like collect your Google address, like your Google email address, and it will tell me how much of the video that you watched. So I really hate that I have to do this because I thought I was going to be able to trust you guys, but just until I can get that trust back, I guess I'm going to have to attach them as Edpuzzle videos and have us watch them through there. Does anybody have any questions for me about that? So I want you guys really, I need you guys to step it up, and I'm doing the same thing with the non-algebra kids. I need you guys to show me. I need you guys to show me what you can do. Watching a video that I took the time to create is definitely one of those things that you need to be able to do at this point. Okay. So let's take a look, and let's take a look at our lesson for the day. So let me come up here. And we're looking at, like I said, in our textbooks, it's labeled lesson number 11. There is a sort of card sort that you're going to need to do on these slides. That's why I handed them out to you with your own copy. But the first piece of it you can actually do in your textbook. So let's take a look at the warm-up for this morning. And let me just grab my book. And it is on 11, number 1, so 11.1, coordinate pairs. So what I want you to do is you're going to take 2 minutes right now. For each equation, choose a value for x, then solve to find the corresponding value that makes that equation true. So I want you to find a coordinate pair, x comma y, that would make each one of these equations true. So that means you're picking an x value, you're plugging it in and solving for y, or you're picking a y value, plugging it in and solving for x. Does everyone understand what this warm-up is asking you to do? Okay, so what I want you to do, you're taking your 2 minutes right now, finding some coordinate pairs that make each one of these equations true. Oh no, we lost somebody. Oh, that was who came in. I wanted to mark that friend. Okay, we're taking one more working minute to find a coordinate pair for each one of these equations that would make the equation true. Once you start to get answers, I need you to throw them in the chat for me. So just do like a number 1 and then write the coordinate pair, number 2, a coordinate pair, and so on. Give me your answers in the chat, please. Remember to write your coordinate pairs appropriately, throwing parentheses around them, please. Writing them appropriately. Nice job, Gabe. Nice job, Connor. Nice job, Gwen. I need answers from everybody. Let's go. Nice job, Gwen. Nice job, Connor. Nice job, Ian. Nice job, Connor. Nice job, Gwen. Peyton, I need an answer from you. Let's see, who else have I not heard from yet? Kyle, throw some answers in the chat. Nassim, Abby, Ava, throw some answers in the chat. John, Junior, throw some answers in the chat. Tyler, throw some answers in the chat, please. I want to see some answers from everybody. I want to know everybody is working hard today. Wonderful. Okay, so let's see. Let's see some of these answers that we got. So let's look at number 1. So Gabe, can you unmute and can you tell me how you chose those answers for number 1?
I chose them because they were, if you multiplied 6 by 7, you would get 42. And if you multiplied 7 by 6, you would get 42.
So the coordinate pair that you got was 7, 6, right, Gabe?
Yeah.
Very good, because if you plug, it was very well said. Nice job, Gabe. If you plug 7 in for x, you would get 42. If you plug 6 in on the right side, you would get 42. 42 is equal to 42. Nice job. I see a lot of people got some decimal answers. So who can talk me through their number 2? Connor, can you talk me through how you made that decision for number 2? Connor, why don't you unmute and just talk us through it, okay?
Fractions are easier than decimals sometimes, so I did it as a fraction.
So which one did, so you just plugged in 1 for x, that was what you did, right?
Yeah, and then 1 1/3 for y.
Very good, because he plugged 1 in here and got 1 times 5 is 5, plus 3 times y equals 9. So 5 plus 3 times y equals 9. Then he subtracted 5 from each side. We got 4 is equal to 3y. Divide by 3, divide by 3, and you get 1 and 1/3 is equal to y. So if he wrote it as a coordinate pair of 1, 1 and 1/3. Good. And I love that you kept it as a fraction, Connor. That's why I called on you, because you kept it as a fraction. I don't want to see people writing decimals like when it's a non-terminating fraction because you don't have access to this key here. I don't want you writing them as decimals because it's not going to be precise. Okay? Keep them as fractions. Good. Now let's take a look at number 3. So, let's see who got an answer for 3. Okay, so for 3, let me just scroll a little bit. Sorry, guys. We could, oh, I saw this answer. Sorry, that was the one that I saw. I just want to grab my, let me scroll it a little bit. Sorry, guys. We got a final answer for number 3 of, somebody put in the chat, 1, 3. So if you were to throw in and, so someone plugged in 1 for x. So if you plugged in 1, it would be y plus 5 minus 1 equals 7. Okay. And then 5 minus 1 would combine to a 4. Y plus 4 is equal to 7. Minus 4 from each side. You get 3 is equal to y. So you pick a y value or an x value and you plug it in. I noticed a lot of people plugged in just like a 1 for x, and that works. That's one strategy. And then there's another strategy like Gabe used where he sort of looked at it and he said, oh, geez, I have a 6 and a 7. How do I make those the same answer? Multiply each side by the other one. Nice job. Both ways work. Is it different in your notebooks? It is different in your notebooks. That's okay. We're just using this one for now. It's not a big deal. Awesome job, ladies and gentlemen. Let's take a look at the learning targets for today. So our learning targets for today are I can find solutions or coordinate pairs x comma y to linear equations given either the x or the y value to start from. So we're going to be finding a total coordinate pair that is the solution, that's x comma y, given either the x or the y value. Okay? So let's take a look at the activity that we're going to do in class for today. So we're going to be using this graph right here to answer some true-false questions. I know in your book it's not colorful, so that's why it's probably going to be important to keep your eyes sort of turned towards the Zoom screen so that you can have more easily see these different equation lines, because I threw some colored lines over top of them so that we could see them a little bit better. So we're going to be using this graph here. So here are graphs representing 3 linear relationships. These relationships can also be represented with equations. We know that. We could write, well, it would be a little bit difficult to find the equations for these ones right here, just because we don't have these grid lines to sort of help us to find these slopes, but it wouldn't be impossible. So if we're looking at, for example, line M, so we're looking at line M, if we're trying to find the equation of line M, we could start with y is equal to, and we know that it hits our y-axis here at 4, so we can start with that y-intercept of 4, and then we would have to sort of find the slope of our line. We know that, so this point sort of falls at 2, comma 2, right? So if we look at that slope, we go down 2 over 2, so we would have plus an x, because our slope would be 1 over 1, which can be written as just an x, okay? That's not what we're doing right now. We're not writing equations, but I just wanted to, nice job, Kyle, sort of take a look at how we could do that. Because it is possible, it's just a little bit challenging with the non-grid line portion. So with this equation right here, we're gonna look at the true and false statements. They're in your book. It says for each statement below, decide if it is true or false and explain your reasoning. So you can do this on the slideshow or you can do this in your textbook. We're going to look at each of the statements and you're going to decide based off of this graph, are they true or are they false? Okay. So that means you're going to go through these 8 statements right here. They're all in your book on that one page. And I'm going to give you 10 minutes right now to read through all 8 of these statements and make the decision. Is it true? Is it false? And tell me why. Does everyone understand what I'm asking you to do for the next 10 minutes? Okay, so what I want you to do is you're going to work right now. I'm going to start a timer. You're going to take 10 minutes to read through all 8 of these statements and decide based on this graph, are these statements true or false? I'm going to leave this on the Zoom screen. If you look, I'm going to leave this graph here so that you can flip back to the Zoom screen and refer back to these equation lines, okay? Does that sound good? Wonderful. You're taking 10 minutes right now to read through these statements and decide are they true or are they false based off of this graph. Nice job, Kyle. Remember, all I'm going to say about that one is I want you to remember the order in which points are written. X, comma, Y, over, comma, up. So number 5 is asking, Max. So there's no solution for the equation for line L that y equals 0. So if you're looking at this line L here, is there ever going to be a point when y is equal to 0? Okay, that's what that one is asking. So Adam, the pink line is line L. If that's like a cursive lowercase l. Which piece, Peyton? Yes. So that pink line right here, let me show you. This is a lowercase l. I mean, this is like a lowercase cursive l, guys. So the pink line is line L. That bottom line, if you're looking at the non-colored version, is the one that's line L. Okay, this is a lowercase cursive l. Okay, we have about 40 more working seconds, guys. 40 more working seconds. taking some time to finish up. I want everyone to throw the answer that they got for number 1 in the chat. So what did you get for an answer for number 1? Did you get true or did you get false? Every single person, I need 18 answers in here. What answer did you get for this guy? Nice job, Kyle. Okay, Abby Wasta, what I need? Ava, make sure you throw your answer in the chat. Cindy, make sure you throw your answer in the chat. I want to see everybody's answer. Let me just, I'm going to have Abby Wasta perfect. Thank you, Ava. Thank you, Junior. Thank you, Ian. Nice job, Sadie. So, Abby, let's take a look at statement number 1. What did you think for statement number 1?
I said false because the line M never hits 0 on the graph.
Good, because remember, coordinates are written x, comma, y, right? And or over, comma, up. Okay, so for this coordinate, that means that line M needs to cross over 4, up 0. So if we go back to that slide and we look at it, let me just click here. And let me go back. So does this line M here, this yellow line, cross at over 4, up 0? That would be this point right here. I think some people got confused and read the coordinate pair as over 0 up to 4, and then that would have been an appropriate pair. So 0, comma 4 would have worked, but it told us that we needed to look at over 4 up 0. So that's this guy on the x-axis right here. So if you're looking at that over 4 up 0, that's not hitting line M. So it's not going to be a solution to that equation. So for it to be a solution to an equation, it needs to be equal to, it needs to hit that line. So this guy right here, we're going to be able to say is false because it doesn't hit that line 4, comma 0. Does that make sense, you guys? Because a couple people said true, but I want you to understand why it's not true. Okay. Awesome. Okay. Nice job. Let's take a look at number 2 now. So that's this guy right here. So the coordinates of the point G make both the equations for M and N, or yes, M and N. So for line M and line N, true. So did we think that this guy was a true statement or a false statement? Throw it in the chat. What did we think? True or false? I need a few more answers. Come on, guys. Throw your answers in. Let's see what you got. Nice job. Awesome. Hey, Max, I need you to help me out. What did you say for this one here, Max? Unmute yourself, buddy.
I said true for this one because I was looking at it and I saw that line M, which would be the yellow line, and the red line, they both cross over G, which would be 2, 2.
Wonderful. So because they cross at 2, 2, that yellow line and this red line, line M and line N, they cross at that 2, 2. Very good. So the coordinate, and that is labeled G. So this would be a solution to both of those equations because that line falls on both of, that point falls on both of those lines. Very good. So we said that this one was true because both lines cross through point G, and that was at 2, 2. Nice job, Max. You gave me a little bit of extra information there, and I loved it because you actually identified what is the coordinate of that point G. Nice job. So now let's take a look at number 3. Number 3 is x equals 0 is a solution for the equation for line n. This one was a little bit tricky. Throw your answers in the chat for this one. This one is a little bit of a trickster, but give me your answers for this one. Okay. Wonderful. So I'm getting some really good answers in the chat there. And this one, like I said, is a little bit of a trickster because yes, this x, the value of x equals 0 would be a solution to this equation. But we need to think about when we're looking at solutions to equations, it needs to come in 2 parts. So you need to know what the x is equal to 0, but you also need to know what the y is equal to. So this one, actually, we're going to say is false, but let's see why. So that x equals 0 would be part of a solution for the equation of line M, but it's missing some information. So we're going to say that it's false because we are missing the y value that would go with the x equals 0. So when we're talking about an equation or a solution to an equation, you need to include both parts. You need to include x equals 0, and in this case, you would need to include y equals 0 as well. You can also write your solution as an ordered pair of 0, 0. So you can't, so this is sort of, like I said, this one's kind of a trickster, and it's just in the semantics of the question because we're missing a piece of it. So if you got this one and you said that it was true, I want you to write down that it's false, and I want you to write down this reason why. This is very, very, very important. So make sure that you get this written down. Okay? Because I don't want you to get confused, and I want you to, when you write a solution, it needs to have both parts. That is the point of this statement here. That is what this point is trying to teach you guys, is that you have to have both pieces when you talk about a solution. Now, let's take a look at number 4. So number 4, 2, 0 makes both the equation for line M and the equation for line N true. This one is another false statement. And the reason that this is false is because 2, 0 falls on neither line M or line N. So if I had picked a point, so in this case, Peyton, you're right. The x doesn't stand for what the slope is. The x is talking about an x value that you could plug in and solve it to get the solution to the equation. Okay. So, as I was saying, sorry guys, if you were looking at this equation here, or if you were looking at these graphs here, sorry, let me just scoot forward a little bit. if you were looking at these equations here and you were looking at line M and you said 0, 4 is a solution to both line M and N, that would also be true because 0, 4 is only a solution to line M. So if you're looking for a solution to both equations, you need to find a sort of meeting point for both of those lines, or a coordinate pair that you could plug into both of those equations and make it a true statement. So let me scooch forward, and we're going to take a look at the last 5 in about 10 seconds while I allow you to finish to copy this down, because if you didn't have these correct, you should be copying these correct answers in. Okay, I'm going to start to erase, and we're going to take a look at the next piece here. I'm going to do it just like I did the last one here, where I'm going to go through these 4 answers here. I'm not going to have too many people unmute and tell me their answers. I'm going to go through them so that we can get through all 4 of them, okay? So there is no solution for the equation for line L that says y equals 0. This was another sort of trickster one. Because if we looked at the graph that we were given on the slide, looks like this guy here, on this section of the grid, we would say that no, there is no point where y is equal to 0 for that pink line. But we need to remember that when we're looking at these lines, they go on forever and ever in both directions. So this guy is actually another false one, because if you extend line L to the going towards the right, it would eventually hit that y equals 0. Okay, so you need to remember that lines are going in, nice job, Kyle. I was just about to put that actually. It would hit that equation line at 7, 0. Okay, so if you were to extend it in both directions, very good, nice job, Max. If you were to extend it, because we're talking about a line, and if you remember the definition of a line is that it goes on forever and ever in both directions. And as Max said, because it doesn't specifically say that these lines are line segments, it says that they're just lines so that they can go on and on in both directions. Okay, good, nice job, point there, Max. Let's take a look at number 6. The coordinates of point H are the solution, are solutions to the equation for line L. And we said this guy was true. Oh, I spelled true wrong. That's kind of scary. So if we look at point H falls along line L here, and it hits that line L. So it's true because point H falls on line L. Okay, now let's take a look at number 7. Number 7 is there are exactly two solutions to the equation for line L. This is another false statement because there are only 2 points that are like labels on that line. But if we remember back to what we talked about yesterday, nice job, Gabe. We said that any point that falls on that line is going to be a solution. I talked about this in that video in the second half, I said that any point that falls here, really like literally every single like micro point. So really this equation has infinitely many solutions. Any point on that line would fall and make that equation true. Okay, last one we're going to look at for this morning is there is a point whose coordinate makes the equation true for all three lines. This guy is another false statement because there is no point where all three lines intersect. Okay, so when you're looking at a graph and it's asking you, is there a point where it's the solutions for all three equations, you're going to have to look for an intersection point between all three of your equation lines. And on this graph right here, we would not have an intersection point for all three of our lines. Okay? So, ladies and gentlemen, your expectation this afternoon, I made another video for this afternoon's portion of the activity. I expect it to be done this afternoon because tomorrow we will be taking a quiz on this content. So let me flip forward here and let me show you what you're going to be expected to do. Okay? So just give me 20 more seconds of your time and then I'm going to have you go out and move into science, okay? So the video link is linked to an Edpuzzle so I can know who watches it and how much you watch. So you're going to click on your cohort number. It's going to take you to Edpuzzle. It's actually going to prompt you to like log in through your Gmail or confirm your Gmail. And I'm not like logged into this class, so I can't open it right now, but it will log you in. And you will complete these activities here, okay? And in the video, it actually talks you through how to complete these activities, what the answers are going to be, and then it prompts you to go through all of these questions here and how to complete this exit ticket on the second to last slide, number 13. So this afternoon, you are completing slides number you are using slide number 7 to complete 8 all the way through the end. Does anyone have any questions before you leave? Once again, I will be checking that Edpuzzle video to make sure everybody watches it. And I'm going to be pushing out our videos now through Edpuzzle. So please make sure that you go ahead and you watch this. If you're not going to be able to do it before the end of the day today, please make sure that you let me know. Everybody has plenty of time though, so I sort of have a feeling you guys can do it, but please let me know if you don't have the ability to because of internet or other obligations that you have. Okay? Wonderful. So you guys can head out to science. Shoot me emails if you have questions. The homework, Kyle, is getting this activity done. So no extra homework other than this activity. The second activity. Thanks, Kyle. Bye, buddy. Bye, everybody.